Welcome to Maths and Science by IITian channel. In this lecture, I will be taking up a very important topic related to factorials for Maths Olympiad and IIT JEE examinations. I will be discussing about the double factorials, that is some n 2 factorials, double factorial for a negative number n. For positive number, single factorial, the values are very well known. When n is an integer, when n is not an integer, that also we have seen from gamma function we can find out. Now, if n is negative and we want a double factorial, what is the meaning of it? Whether double factorial will be applicable to the negative values, negative integer values or negative values? Let us try to develop the concepts for a double factorial of a negative number in this lecture and we will try to solve it. That's our aim for this lecture, and it will be very much useful for Maths Olympiad, for factorial questions and also for IIT JEE factorial questions. It is an extension of knowledge of single factorial to double factorial. It's a very good concept. Let us try to solve this problem. Question is, find minus 101 double factorial is equal to how much? Only simple question. It will be dealt in different ways. I will be discussing the procedure as per number theory, not involving much of calculus and integration. You can do with calculus and integration also. Here we are required to find the value of minus 101 double factorial. Here we are required to define the meaning of the double factorial and also to find whether for negative values double factorial exists. The solution goes like this. First part is to define what is double factorial. A double factorial of n is defined as n double factorial is equal to n into n minus 2 into n minus 4 up to 2 when n is even, and its value will be n into n minus 2 into n minus 4 up to 1. The last value will be 1 when n is odd. This is the meaning of the double factorial of any number n. If, for example, we will take an example, if n is equal to 6, then 6 double factorial is equal to n double factorial is equal to 6 double factorial, that is 6 into 6 minus 2 into 6 minus 4, that is equal to 6 into 4 into 2, that is equal to 48. It's for even, when n is even. When n is odd, like n is equal to 7, that implies double factorial n is equal to 7 into double factorial 7 is equal to 7 into 7 minus 2 into 7 minus 4, it's not 3. 7 minus 4 into 7 minus 6. It's not 5, it is 6. So that is equal to 7 into 5 into 3 into 1. It's not 5, say 5, it is 6, 7 minus 6. Then that value comes to 35 into 3, which is equal to 105. That means the double integral for even numbers and odd numbers are found to be different, and the double factorial, from the definitions, we use these definitions of double factorials and we will find for positive n and also negative n. Here negative n is given, n is equal to minus 101. When n is equal to minus 101, how to proceed? That is the point of contention here. Recurrence relations are, please keep in mind, from the above it is n double factorial is equal to n into n minus 2 double factorial. If n is equal to odd, n is equal to even, that is from the definitions. And from this we get 0 double factorial is equal to 1 and minus 1 double factorial is equal to 1. As we have told, n double factorial is equal to n into n minus 2 double factorial. That implies n minus 2 double factorial is equal to n double factorial by n. This is also a very important deduction from the above definitions. Now, if n is equal to 1, what happens? If n is equal to 1, it says n minus 2 double factorial is equal to 1 minus 2 double factorial, that is equal to 1 double factorial by 1. That implies minus 1 double factorial is equal to 1. It is proved, this one is proved from this equation. N minus 2 double factorial is equal to double factorial n by n. When n is equal to 3, why I will be dealing with odd numbers? Because 101 is the odd number. N is equal to 3. What happens? Let us see. 3 minus 2 double factorial is equal to, what is that? double factorial 3 by 3, that is equal to 1. That means 1 double factorial is equal to 1. This also, now we have to prove 0 double factorial is equal to 1. Let us say n is equal to, that when you put even number n is equal to 2, because this formula is valid for any number. When you put n is equal to 2, 2 minus 2 double factorial is equal to double factorial 2 divided by 2, that is equal to 1. That means 0 double factorial is equal to 1. This is also proved. When n is equal to, let us say, minus 1. What we have done till now, n is equal to positive values. N is equal to 1, n is equal to 0, 1 is equal to 2, n is equal to 3. Now we will go n lesser than 0. N is equal to minus 1. That implies from the definition, minus 1 minus 2 double factorial is equal to minus 1 double factorial by n minus 1. That is equal to, what is that? That implies minus 3 double factorial is equal to minus 1 double factorial is equal to 1. That we know. 1 by minus 1. 1 by minus 1, that is equal to minus 1. Now, let us say, when n is equal to minus 3, that implies minus 1, minus 3, minus 2 double factorial is equal to minus 3 double factorial by minus 3. What is minus 3 double factorial is minus 1 by minus 3, that is equal to 1 by 3 minus 5 double factorial. That means like this we are getting the values, and from the induction principles, you take it as a homework, prove that, we can prove that minus 2k plus 1, because we are interested in odd negative numbers, because we have to find out minus 101. Double factorial is equal to minus 1 to the power of k by 1 into 3 into 5 up to 2k minus 1. That implies the final formula will be minus 2n plus 1 double factorial is equal to minus 1 to the power of n whole divided by 2k plus 1 factorial. This is the formula for finding the, here we have not used the calculus, we have not used the gamma function. We can use the calculus and gamma function also and we can prove this. By induction we have proved, and by calculus and gamma function also we can prove. You take it as a homework. Try to prove above with the help of gamma function, which I have explained in my previous 2 classes. Now, (2k) here it is double function, double factorial. Here it is double factorial. Here we need not write the double factorial because itself it denotes, it's an odd number. 1 into 3 into 5 into 2k minus 1. Here it is, we can say instead of 2k we have to write it as 2n plus 1 double factorial. Now, this particular formula, you please treat it as a homework and prove it. If you have any difficulties, please put a comment so that I will send the proof to you. It's very simple. And now, we have to apply this formula for this whole, this one, because minus 101 I want. This one has to be 101. Please try to understand. 2n plus 1 is equal to 101. That means 2n is equal to 100. That implies n is equal to 50. That implies minus 101 double factorial is equal to minus 2 into 50 plus 1 double factorial. Here n is equal to 50. Then apply this in this formula, minus 1 to the power of 50 whole divided by 2n plus 1. 2 into 50, it is not plus, it is 2n minus 1. 2k minus 1, here I have to write it as 2n minus 1. 50 minus 1. That implies minus 101 double factorial is equal to 1 divided by 99 minus 1 is 100 minus 1 is 99. 99 double factorial. Now the question is, how to find out 99 double factorial? From the same formula, how to find out 99 double factorial? If you want to convert double factorial to a regular factorial, then there is a formula called 2k minus 1, or we can even say 2n minus 1 double factorial is equal to 2k factorial, which I have explained 2 to the power of k into k factorial. How to get the 2 to the power of k or 2 to the power of n, that I have explained in my previous lecture. Please see that, because here it is n, I will write it like this. 2n factorial whole divided by 2 to the power of n into n factorial. Now, I want 99 double factorial. Because here it is negative, hence I got it in positive values. Now positive double factorial I am finding, that is equal to 99 can be written as 2 into 50. Please try to understand this step. 2 into 50 minus 1 double factorial, here n is equal to 50. So 2 into 50 single factorial by 2 to the power of 50 into 50 factorial. That implies 99 double factorial is equal to 100 factorial divided by 2 to the power of 50 into 50 factorial. That implies 1 by 99 double factorial is equal to 2 to the power of 50 into factorial 50 divided by factorial 100. That implies, what is minus 101 double factorial we wanted. Hence, minus 101 double factorial is equal to 1 by 99 double factorial, that is equal to 2 to the power of 50 into 50 factorial by 100 factorial. This is the answer if you want it in factorials. Simplified answer. That means there will be double factorials for negative integers also. If there is any conception that for negative integers there are no double factorials, please remove that. There for double factorials, for negative integers also there is a value for double factorials. With this, I want to conclude this lecture, and it's a very important lecture, and If one of the answers in the examination is given as -101 or -10 or -2000 double factorial, and one of the answers will be definitely given as it is undefined. No, the value is defined. Double factorial negative values are defined. And this is how we have to arrive at the double factorial value. This is double factorial of 2n minus 1. This is for positive values. Then we have to use for negative values minus 2n plus 1 minus 1 to the power of n by 2n minus 1 double factorial. This 2n minus 1 double factorial we will get from here. Did you understand? The two important formulae are, one is two important formulae which we have deduced are minus 2n plus 1 double factorial is equal to minus 1 to the power of n minus 1 to the power of n divided by 2n minus 1 double factorial, in which 2n minus 1 is not defined, and we have to use the 2n minus 1, and these two formula we have to use together. 2n minus 1 double factorial is defined as 2n factorial. To convert it into single factorial, 2n factorial by 2 to the power of n into n factorial. How this is to be done? Please try to understand these two equations. These are the vital equations for finding the double factorial for a negative value. These two equations, you please try to understand them. See the video repeatedly. If you have any problem, please comment in the comment section. I will reply, and we can get the answers from these equations. Please try to, I have proved one of the equations, second equation. You try to prove as a homework and see that you will grasp the concepts well and do better in the examination. Best of luck to everybody. Thank you for listening to me, and thank you for viewing my lecture. And if you have value addition because of this lecture to you, kindly share and subscribe to my channel Maths and Science by IITian. We will go for a very good problem in the next lecture. A to the power of b plus b to the power of a is equal to ab factorial. We try to solve it in the next lecture. I thought before this, actually I wanted to solve this, but before this I wanted to give an introduction about the negative double factorials also. Thank you for listening to me. Best of luck to you.